Let us compare finding the area of a trapezium with finding the area of a square. Our argument is that a square is a trapezium. That means in the set of all trapezium, a square is a member of that set. We will use the property of area to demonstrate that a square is actually a trapezium. How will we do that? We will do that by using the formula for finding the area of a trapezium to find the area of the square and show, as a matter of fact, that the area of the square by using the formula for the area of a trapezium will give us the area of the square if we were to use the typical formula for finding the area of a square. All angles are right angles and opposite sides are parallel. That's a property of a square that is well known. We don't need to reiterate. Now, here we have the formula for the area of a trapezium. What we have here are symbols. And it does not matter what symbols we have here. The two numbers that are added inside of the brackets will be the two parallel sides. H1 and H2 are the two parallel sides of a trapezium, because we are treating the square as a trapezium. Opposite sides are parallel, so choose any pair of opposite sides. In a square, opposite sides are parallel. So if we can get a hold of a pair of parallel sides, then those values will take their places inside of the brackets right there. So we are using the upper and the lower sides of the square. They are equal. The upper 5 centimeters and the lower is also 5 centimeters. They are parallel. Now, this is the perpendicular distance between the two parallel sides. If these are the two parallel sides concerned, we know that all of the angles are right angles. Therefore, here is perpendicular to these two sides. If we choose two parallel sides of a square, any of the other two sides will be perpendicular to these two. That will be B. B is required to be perpendicular to the two sides that we have chosen. B is the perpendicular distance between the parallel sides. The side perpendicular to the two parallel sides of 5 centimeters is also 5 centimeters. This side is 5 centimeters. It is perpendicular to the other two sides that we have chosen. So it may take its place right there. All that we need to do is simplify the arithmetic expression. And we did that by taking the first step of adding these two. 5 plus 5, that's 10. The 5 over 2 is retained. Next, we will simplify by a common factor of 2. 2 into 2 is 1, and 2 into 10 is 5. Next, it is 5 times 5, and that will give us 25 square centimeters or centimeters squared. Also, we will take a look at the typical way of finding the area of a square. The area of a square is the square of the length of any sides. All sides are equal. The area of the square is the square of the length of any side. There we have 5 squared, which is equal to 25, and we also have 25 square centimeters. This is one way in which a square adheres to the properties of a trapezium. Now we will show that it is generally true. On this occasion, we will not use numbers, but show that the proposition is generally true by using symbols. If the expressions in the end are the same, then we are sure that we can make a general statement for the area of a square being equal to the area of a trapezium. That is, the trapezium that we imagine that we can make out of this square. All angles are right angles, opposite sides are parallel. H1 and H2 are the two parallel sides. Opposite sides are parallel, so choose any pair of opposite sides, and we will choose these two. It doesn't matter. All of them are of equal length, and opposite sides are parallel. So that one, the upper, is parallel to the lower, and we may use them. B is the perpendicular distance between the two parallel sides. The side perpendicular to the parallel sides of length L is also of length L. The side that is perpendicular to these two, which is the perpendicular distance between these two, is this one, which is also of length L, and we don't have to grope and we don't have to use anything to enhance our view to discover that this is perpendicular to these two, because we know that opposite sides of a rectangle are parallel and all of the angles are 90 degrees. They are right angles. The sides are perpendicular. L goes there, the perpendicular distance between the two sides that we have chosen as our parallel sides. Simplify the arithmetic expression. We will begin L plus L, that's 2L. Then we will simplify by a common factor of 2. Those two in numerator and the denominator will be cancelled, and all that we have left is L times L, which is equal to L squared, which is what we have here. We are just reiterating by showing it right here that the area of the square is the square of the length of any side. We know that already, and no doubt we will choose any of these to be substituted right there, which is, of course, as I said before, just reiterating, and we have L squared. Notice that the expressions are the same, and we are sure that the area of a square will be exactly the area of the trapezium if the square were to be treated as a trapezium. In the context of finding the area, the square behaves exactly like a trapezium. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.